Good evening. So let's begin with today's question, which is rotate a number. So what we given here? We have given a two numbers n and k. We are required to rotate n k times in the right to the right. If the k is positive, rotate to the right and remove rightmost digits and make it leftmost. Do the reverse for negating value of k. Also, k have the absolute value larger than the number of digit n. Take as input n and k. Print the rotate number. Note, assume that the number of rotations will not cause leading zeros in the result. Example such as input will not be given. So here is the one example here. 1, 2, 3, 4, 0, 5, 6. We rotated it 3 times. So what will become? So 0, 5, 6 will come in the leftmost position from the rightmost. So the number is 0, 5, 6, 1, 2, 3, 4, 0. Correct? So let's begin here. So what we're going to need here? Let's say there is a number 164589. This is a number we have given, and this is let's say n is equals to, and this is k is equals to 2. We have to rotate this number by 2 times. Means we have to move this 89 in the front here from rightmost to the leftmost. How we do it? How we do it? So there is a easy way to do it. They say k is equals to 2. The number of times we are going to rotate the bell. This is the exact value we need to divide the number, our original number with. Let's say we divide the original number with 10 to the power 2, which is equals to the k. It will become 100. So when we divide 6, 4, 5, 8, 9, more or less say modulus of 100, what will become? Quotient will equals to 4, 5, oh, sorry, 1, 6, 4, 5, and the remainder will 8, 9. You get this? So this is the first step of our question. Now we got it. Now we have to find the number of digits in quotients, which is equals to 4. We know how to find this using the while loop, which we previously did in the previous program. So now what we going to do? See with careful. Now we multiply. Now we multiply then our remainder with the 10 to the power number of digits of q. So what is the number of digits of q? NOD 4. So what will be become the number, our number of our divisible here, multiplication here, which will equals to 10 to the power 4, which will equals to, right? So now we multiply our remainder with this, we will get the answer 89000. Now what we going to do? Now we add our quotients with this number. We add our quotients. So the final number will be quotients plus remainder, which will equals to the 89000 plus 1645. what will be the number now? It will be become 891645. So our number is actually rotated two times. 89, two numbers have rotated from leftmost to the rightmost. 1, 2 goes to in the front. See? Now, let's begin with the code. So here is our code. K is number, N is a number, K is the number of time rotation. Now see what we're going to do. int nod is equals to 0 and int temp, just see how we do it, is 0, and then we use while temp does not equals to 0. Oh, here, and equals to 0. What we do, we just divide our number. Right, and increment our number. This is the program we already did before for counting the numbers. Okay, so we did it here. Now after that, what we do, we handle some exceptions here, which is given here. They say do the reverse for negative value 2 and the k could be the larger than the digit of n. So we handle both of those two cases, like how k, if the k is say the larger, k will equals to k modulus NOD. Like how it works, I will say. Let's say they say if the program says that we have to rotate our number by 352 times. So rotating the number 352 is the same number which we already have. So we have only to rotate 2 times. So we take its modulus, and with the number of digits we have, it takes our modulus and put it into the k and rotate with the new value of k. Okay, so we handle the first exception. Now handle the second. If k is less than 0, if k is negative, then we have to let's say k plus is equals to NOD. Like how if they say that rotate the number by -2 times. So they actually say rotate the number by -2 times. So what we going to do? -2, if we add our total numbers in -2, rotating these two numbers is a positive response. Rotating these two numbers will be the negative. So if we add our total numbers, so there are 4 digits here. So they say -2. If we add our NOD plus NOD here, which will equals to -2 plus 6, which will equals to 4. So we actually need to rotate it 4 times. So we need to rotate this number. This number will go in front, and this 1 6 will become in back side. So the original program says if the positive number, then the number is from rightmost go to leftmost. If the number is negative, then the leftmost will become rightmost. So for doing this, we do not handle the negative numbers. We just make it positive by adding the total numbers of digits available in our number. So we did it here, and now what we're going to do? We just int divisible is equals to 1 and int and say multiplier is equals to 1. We just initialize it and use loop for int I is equals to 1, I is less than equals to NOD and I plus plus. For loop, we use if loop inside. I will explain our code later. Let me write it first. I is less than k, then divisible is equals to divisible multiplication, say multiply by 10, okay, and else multiplication by 10, as I already explained in our Word file. So now what we're going to do is just our quotient say n y division and int reminder will be n modulus divided. Okay, so after that int r will become final result will become remainder multiplied by multiplications plus QUO quotient, and they just print our code, which is system dot out dot println, and what we're going to print r. Okay, so let's see it's working or not. We get the wrong answer. Let's see what's wrong. We provide our own input, that is 1 2 3 4 5, and our input will be, let's see, 2 times. The number should be 4 5 1 2 3. Let's see what's I have given the inputs, run the program. 2 3 4 9 4 5 1 2 3. Number is accepted and working completely fine. Let's see. Number is working completely fine. I give the input 1 2 3 4 5 and rotate it by 2 times. We rotate it 2 times, means 4 5 1 2 3 will be our output. So see here, 4 5 1 2 3 is our output, accepted.